So delayed. Okay, so this lesson is all about statements, conditionals, and biconditionals. It's a fancy way to say something actually pretty simple. Students will write and analyze compound statements by using logic. So that's what we're doing. You saw that in the warm-up where you're just answering true or false to these statements, just logically reasoning through those statements. If an object is red, then it is not blue. True. If an object is not red, then it is not blue. Well, it could be blue. So if you can think of a scenario where, like one scenario where this wouldn't work, then the statement is false. If an object is not blue, then it is not red. Well, it could be red, so that is false. If an object is blue, then it is not red. True. These right here are called conditionals. It is when you put two statements together, an object is red, it is not blue, with an if-then. That makes a conditional. For number 5, it says rewrite this statement as a true if-then statement. So, an even number is divisible by 2. So we're going to write it as a conditional. So we're going to write if a number is even, then it is divisible by 2. Let me make sure the wording is the exact same. Okay. If a number is even, then it is divisible by 2. So there is our conditional. Okay, so a couple things within this conditional that we need to pay attention to. We have the if-then statement, if and then. The statement after the if is a hypothesis. And the abbreviation for hypothesis isn't what you would expect. It is a P. Don't ask me why. Maybe I need to Google that. And then the part after the then is the conclusion, and the abbreviation is a Q. Actually, it has to probably do with statistics, possibly. Okay, so today we're dealing with hypotheses and conclusions and reasoning. I had you fill in this box right here. And I'm going to do kind of like an abbreviated version over here, so that way you can easily have like a cheat sheet of things to look at. Over here I'm going to write 4 words and I'm going to leave space. So we're going to have conditional, converse, inverse, and contrapositive. And again, leave yourself space because we're going to put in stuff in between those. Okay, so for conditional, I just showed you it's if the hypothesis, then the conclusion. There's an abbreviation for this, P, then Q. So the way we would say this with words is if P, then Q. Period. The converse of this is if we switch this thing around and we said, okay, Q, then P. So if Q, then P. To Q right here. Okay, so how would this look with an actual scenario? So going back up to this first scenario, we have the conditional. If a number is even, then it's divisible by 2. The converse, we're just switching it around and putting the if here. If a number is divisible by 2, then the number is even. So you're just flipping it around. Then for inverse and contrapositive, there is a symbol that looks like this. And this symbol means not. If not P, then not Q. So if not P, then not Q. So showing this in the example, if a number is not even, then it is not divisible by 2. And then contrapositive looks like this, not Q, then not P. And then looking at the actual example here, if a number is not divisible by 2, then the number is not even. Okay, one more thing, because this is going to be kind of like your cheat sheet for this. So it's all in one place. Of course, hypothesis is your P. Conclusion is Q. And then the hypothesis would be if, then the hypothesis, and conclusion would be then, and then the conclusion. Okay, next page. Or not yet? Not yet. Okay. Ready, set, go? No? Okay. Next. Okay. So for this lesson, there is quite a few examples and a lot of writing. I'm going to skip some examples. I'm also going to kind of alleviate some writing. Here it has us writing out the hypothesis and conclusion. Instead of writing it out, we're just going to circle it in the example. So hypothesis, we're going to use circles. So anytime we are needing to identify the hypothesis, we're just going to use a circle. And then conclusion, we're going to use a square. I will differentiate between color to help, but obviously not everybody will have color. And remember, the hypothesis is after the if, and the conclusion is generally after the then. We'll see some examples where it's not, but okay. So based on that, identify the hypothesis and the conclusion. Remember, hypothesis is P, conclusion is going to be our Q as well. Okay. So, if a polygon has 6 sides, so that would be our hypothesis, a polygon has 6 sides, then it is a hexagon. So square around the conclusion. Okay. This one, it doesn't normally happen like this, but it's like, okay, if it's put this way, another performance will be scheduled if the first one is sold out. So in this case, our hypothesis is actually right here after the if. If the first performance is sold out, another performance will be scheduled. And the next one, if the forecast is rain, so we'll circle that, then I will take an umbrella. There's the conclusion. And another one that kind of is in a weird format. A number is divisible by 10 if its last digit is 0. So here is the hypothesis after the if, and then the conclusion. Okay, so something to notice in these statements is the hypothesis is like the cause, and then the conclusion is the effect. So in the next part, it's going to tell us a statement, and we have to put it in an if-then format. So here it says 4 quarters can be exchanged for a $1 bill, and we have to create the hypothesis and conclusion and then write it in an if-then. Hypothesis would be the cause if you have 4 quarters. So you have 4 quarters. The conclusion, it can be exchanged for a $1 bill. You can exchange for, we'll just abbreviate, $1. And then in an if-then, if you have 4 quarters, then you can exchange them for a $1 bill. So we have hypothesis and then conclusion here. So far so good. Okay. For the sake of our brains, just because this becomes like a lot of writing, we're going to skip this one and this one. Move on to example 3. Okay, so in this one, it gives us a large scenario. We are going to write, and I'll get to what it says here, we're going to write a conditional, a converse, inverse, and contrapositive. So conditional, converse, inverse, and contrapositive. Leave some space so you can write as well. So the abbreviations, just to remind ourselves, conditional is P, then Q. The converse would then be Q, then P. Inverse would be not P, then not Q. And contrapositive would be not Q, then not P. Okay, so it gives us a whole situation. We don't really need to know all of this. It says, write the converse, inverse, and contrapositive are the true conditional statement. So here is the actual statement they want us to consider. It says, I'm going to zoom in so you can see better. Oof, that's a little too much. Zoom out. Okay, tangs are fish that live in salt water. So to put this in an if-then, if a fish is a tang, then it lives in salt water. If a fish is a tang, then it lives in salt water. Okay, true. Okay, then the converse of that, we're just going to switch that around. If a fish lives in salt water, then it is a tang. If a fish lives in salt water, then it is a tang. So we just switched it around, but there's lots of fish that live in salt water and they are all tangs. So this one is actually false. So if you can think of one example where that statement would be false, then the whole thing is false. Okay, inverse. The best way to come up with the inverse is to just look at the conditional, because it's in the same order, P then Q, and just put a not in there. If a fish is not a tang, then it does not live in salt water. That doesn't make any sense because there's a lot more fish that could do that. Let's see. So this one would be false. And last but not least, contrapositive, not Q, then not P. So what I'm going to do is go up to the converse because it's already in that order and just put a not in there. If a fish does not live in salt water, then it is not a tang. If a fish does not live in salt water, then it is not a tang. That one is true. Tangs have to live in salt water. Okay, so that's how you write those statements. We're going to skip this little part, her. Okay, next. Okay, last concept. Biconditional statement. Okay, biconditional statement. A biconditional statement. Oh, did I say? Biconditional statement is the conjunction of a conditional and its converse. Okay, what does that mean? So some situations, I want to go back to our other example. Let's see. So in some situations, for example, our conditional and our converse are not both true. So in this case, our conditional was true. You don't have to flip back, just look up here. In this case, our conditional was true, but our converse was false. But in some situations, both are true. So for example, in the first example, we could say if a number is even, then it is divisible by 2, or we could say it backwards and say if a number is divisible by 2, then it is even. That would be a case where the conditional and the converse are both true. When that happens, we can actually make a biconditional. And with biconditional, we will say the words if and only if. So let me show you an example. We're going to, don't cross it out because we might come back to this, but over here, we'll do this one right here. What's up? This one? Let's see. Okay, so we're going to do this example right here. So it says isosceles triangles have at least 2 congruent sides. We're going to write a conditional. So if a triangle is isosceles, then it has 2 congruent sides. You may remember this from like elementary or middle. An isosceles has 2 congruent sides. The converse, so conditional would be P then Q. The converse would then be Q then P. If a triangle has 2 congruent sides, then it is isosceles. That is true as well. So in this case, the conditional is true, and so is the converse. So we can write this, instead of writing these 2 statements, we write it as a biconditional. If, actually, I'm going to take out the if. A triangle is isosceles if and only if it has at least 2 congruent sides. I'm going to stop there. Okay. So we're going to stop there, so that way you have the rest of the class to do the homework on this. We don't have the laptop cart today, so you are going to need to use your phone to do your homework. If you finish your homework, then work on Alex for the rest of class. Please use this time wisely, and you can get your phones. I'll enable the homework